This tutorial video is designed to help you go from scientific notation to standard form. Standard form is just a regular old way of writing a number, but scientific notation is an abbreviated way of writing a number, almost like a shortcut. So instead of saying like grade point average, you say GPA. It's a shorter way of saying or even writing grade point average. So scientific notation, it's the way that you can write really large numbers or really small numbers. Okay, so scientific notation, it makes me think of science. This is something that you will use in science a lot, especially if you become a scientist and you are dealing with like planets, the solar system, atoms, stuff that's either really big or really small. Okay, so I have these numbers in scientific notation, which is great, but we're not really familiar with scientific notation that much, especially in 8th grade. You know, it's a little bit newer of a concept, and so they don't really mean anything to me. I don't really understand how big these numbers are or how small they are, and so I want to get it in standard form so it looks like a number that I understand. Okay, so what you're going to do is you're going to take the first number, this is called the constant, and you're going to write it down. Okay, and to get it in standard form, we are going to move the decimal the exponent number of times. Okay, so I see an 8. So I need to move the decimal 8 times. If it is a positive 8, you're going to move it to the right because right is a positive movement. If it's a negative 8, you're going to move it to the left because left is a negative movement. Okay, so I see a positive 8, so I'm going to move it to the right 8 times. So my decimal is going to move 1, 2, 3, 4, 5, 6, 7, 8. Okay, I didn't even have enough numbers to do that. So anywhere that you have a little loop but no number, you're going to put a 0. Okay, and then I'm going to rewrite it to make it nice and neat. There's 7 zeros. Okay, and then that's still hard to read, so we need commas. You start on the right side, and every 3 you put a comma. Okay, now my decimal at the end, I did not put it because when a decimal is at the end, it's not necessary. Okay, so it's not that I forgot to put it. When it's at the end and we actually physically moved it, it's no longer here, we had moved it to the end, we don't need to put it. Okay, so basically I have 140 million. That is the standard form. So the shorter way to write 140 million is 1.4 times 10 to the 8th. So here's a little fact for you, is if you actually had put this in your calculator and solved it, the answer would be 140 million. So by just putting this scientific notation equation into standard form, we actually solved it without having to do 10 times 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 1.4. Okay, so it actually was a lot easier to just move the decimal, put it in standard form. We solved it, which is standard form, but now that's a number I can understand. Okay, so let's do the second one. So the first thing we're going to do is write the constant, which is the first number. And we are going to move the decimal the exponent number of times. So it's a positive 2, which means we're going to move to the right twice. Okay, so we get 325, and there's a decimal on the end, but when the decimal is the last thing, we do not have to put it. It is not necessary. Okay, and then there's only 3 numbers, so I don't need to put a comma. It's just good how it is. Okay, let's do one with a negative exponent. So I need to write my, sorry about that. I need to write my constant, my first number. Okay, and I need to move the decimal to get it into standard form. I need to move the decimal exponent number of times. So this time it is a -4. So I need to move it left 4 times. So my decimal is now at the front, and I'm going to fill it in with zeros. When your decimal is at the front, it is extremely important. And I've had students in the past that want to come put commas, but when the number is less than 1, it does not need commas. Okay, or I guess I should say not less than 1. When a number is between 0 and 1, when it's a decimal, it does not need commas. Okay, so let's do the last one. Write the constant, move the decimal exponent number of times. So it's a -6, so I'm going to move it 6. I'm going to fill in my loops with zeros, and I'm going to rewrite it. The decimal is at the beginning, so it's very important. This is between 0 and 1, so I do not need commas. Okay, so the last thing I want to point out is when we talked about laws of exponents, I said that we didn't want negative exponents, so why do we have that here? Well, if you remember from laws of exponents, we would move that negative, we would make it a fraction and then move it to the bottom. So we would get, oops, it's 2, 1, sorry. So we would get this. Well, that is a fraction, and a fraction and a decimal, they're just different ways of writing the same thing. And didn't I get a decimal? Okay, so that's a little advanced for 8th grade, but just in case you were like, why does she have negative exponents? We learned that you shouldn't. Well, basically, if you were to get rid of the negative exponent, you would end up with a fraction like I did here. Okay, and a fraction and a decimal are equivalent. They're just different ways of writing the same thing. Okay, so you don't actually have to move the negative exponent for scientific notation, but if you're curious where it came from. Okay, so 140 million is the same as 1.4 times 10 to the 8th. If I was to put 3.25 times 10 squared into my calculator, I would get 325. But an easier, simpler way to solve it is just by putting it into standard form. Okay, especially when you're dealing with really, 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 really big or really, 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 really small numbers.